Hello friends, my name is Pankaj Bhusari. I am working as an assistant professor in Marathwada Institute of Technology. Recently I am teaching the subject that is Computer Communication Network. So in this slide, we will see the basics of network. First, what is my network? It is the connection of different nodes and the link in between them. That is called the communicating link. What are the nodes that we are using in the network? It is called either we can use for the computer or the shared resources. Now what is the shared resources? The resource which has been used by the multiple nodes. For example, a single printer, it has been used by the multiple PC and it can be used as a shared resource. Then what is the need of network? If I want to transmit the data over a long distance, then I can go for the network. Then network it categorized based on their different parameters, like first one is the geographical area, next one speed, and after last one is the capacity of network, means how many number of bits or baud a network can transmit from sender to receiver. Now there are different parameters of the network. We will learn them shortly. First one is the network coverage. Depending on the geographical area, network is classified into three types, that is local area network, metropolitan area network, and last one is the wide area network. Now we have used the LAN, that is local area network, where the geographical area is less. For example, labs at colleges, where the number of nodes, that is number of PCs, are less in number. Then the metropolitan area network, whenever I have to transmit the data over a city, then I can go for the metropolitan area network. The best example of this MAN is broadcasting a cable television over an entire city. The last one that we are using, that is WAN, wide area network. If I want to transmit the data over entire country, then I can go for the WAN, in which different number of nodes are interconnected with the help of MAN and LAN. Then what is my topology? It is the way of connecting the different nodes into the network that will decide the topology. Now it depends on the user how it is going to connect that nodes into the network. It is divided into 5 to 6 types, that is mesh topology, star topology, then hybrid topology, bus topology, and the combination of all these, it is called the tree topology. You can use any one of this topology. Then we will move to the next slide. Now this is the basic model of any computer network. It is called a reference model. Its name is OSI, that is Open System Interconnection. It has been given by the most standard organization, that is International Standardization of Organization, which will set the some protocols while sending the data from transmitter to receiver. Now suppose without internet I have to transmit some data from one PC to another PC, then I can use only for OSI model, that is Open System Interconnection model. Now we will see the different layer of this model. It includes 7 layers, starting from the physical to the last one, application. That is the bottommost, and the last one is application. Now we will see each layer in step by step along with their parameters. Now what is the function of this physical layer into the network or the reference model? Physical layer, which will transmit the data in terms of bits, that it will decide the bit rate of the system. Number of bits transmitted per second, it's called bit rate. Then it will do the encoding of data or channel. Then how the data is transmitted, either half duplex, full duplex, it has been decided by the physical layer. Next one is the data link layer. Then what are the parameters of this data link layer? First one is the error detection, then flow control, after that MAC, that is media access control, What will error detection do? It will find the error in the received data, and once the error has been detected, it has been removed with the help of error correcting algorithms. Then what is my flow control? Means how many number of frames or bits the physical layer is transmitting to the data link layer. Its flow has been controlled by the data link layer. We have used 3 algorithms in the flow control. One is stop and wait protocol, then go back and selective repeat ARQ. These are the 3 basic algorithms we use in data link layer under flow control. Next, the data has been transmitted to the next layer, that is upper layer, network layer. The function of the network layer is to provide the addressing. The next parameter is routing, and the most important is providing the protocols, that is IP4 and IP6. Then what is the need of addressing? The network must know the address of 2 aspects. One is the sender's address, another is the receiver address. Then and then the data know from where to start and where to end. So each frame is having the starting address along with the ending address where it has to receive. Then the next parameter in the network layer is routing. It is the way of transmitting the data into the network on the different nodes that will explain the routing. There are 3 types of routing. One is circuit switching, another is packet switching, next one is the message switching. It is also called as a load and store switching. Then the data is going to transmit to the next layer, that is transport layer. It will provide only end-to-end communications or end-to-end delivery of data. That is the function of transport layer. Next one is the session layer. What is the parameter of session layer? That is authentication, permission. Then it will provide the session. After that, restoration of the session. Authentication means if some user wants to enter into the system, then through this layer we can enter with the help of ID or password. Then and then this network will give the permission to the user. Then the data will go to the next layer, that is presentation layer. Here we are doing the encoding, decoding, encryption, decryption, and the compression of data in the presentation layer. Now what is the role of that encryption and decryption of data? While transmitting data from sender to receiver, we have to take care about the security of that data. So for that we are using encryption and decryption algorithms. Next, the data will be transferred to the topmost layer, that is the application layer. In that we are using the HCI, that is human computer interface. Why we are using that HCI? Because we are unable to read the language of computer which is working on 0 and 1s, and computer can understand our human language. So in between there should be a GUI, that is graphical user interface, so that we can understand both language. That is the role of application layer. The best example of this OSI or reference model is when you are transmitting data between 2 mobiles without internet with the help of different applications like ShareIt, another is Zapier. At that time you can go for the OSI reference model. What is called reference model? It is the basic model, and we have all the devices, those who are want to transmit the data over the network without internet, they can go for this layer, that is OSI layer. Now the next layer is, or the next model is TCP/IP model. It is called transmission control protocol. IP is internet protocol model. Whenever you are transmitting the data over a network, but here with the help of internet, then at that time you must have to use the TCP/IP model. This is our previous one model, that is OSI reference model. Same 7 layer has been used in the TCP/IP model, but some of the layers get merged or embedded. Now, what are the layers present in the TCP/IP? First one is the physical and data link layer. Both the layers get merged in the TCP model. It has been called the host to network, or the other name is, we can see here, the data link layer. The same function is performed here in TCP/IP model as that of used in the OSI model. Now the data will transmit to the next layer. Here TCP model contains only 4 layers, that is data link, internet, transport, and last one application. The basic bottommost layer, it is called data link layer. Another name is host to network layer. That we can use for the different protocols, that is 802.x. It has been the IEEE name given for the transmission of data. For example, IEEE 802.35. If I am using the 802.5, it will be the ring topology given by the IBM. Now what are the data that will come to the data link? It has been transferred to the internet. In the internet we have used two configuration. One is basic internet protocol version 4 and internet protocol version 6. Generally we go for the 6 because it is having the more upgradation capability or more configuration than 4 or more add-ons software. Now the data will transfer to the transport layer. In the transport layer we confirm the end-to-end delivery of data. In that we are using the two protocol, that is TCP, another is UDP, transmission control protocol, and user datagram protocol. While TCP is connection oriented and the UDP is connection less. In TCP, once you have transferred the data over the network, it will care about the faithful reception at the receiver. It means you are getting the acknowledgement back in TCP. While in UDP you don't get the acknowledgement. So it is called connection less system. That is UDP protocol, user datagram protocol. Then the data will transfer to the last layer, that is application layer. In the application layer we are using the different protocols, that is STTP, hypertext transfer protocol, SMTP, simple mail transfer protocol, or FTP, that is file transfer protocol. Other protocols that we can use in application, they are DNS, that is domain name system, or recently we are using the telnet. All these protocols are going to use in the application layer. This is the basic TCP/IP model. Now here I have to tell you or taught you the two models of a network, that is OS and TCP/IP model. Now the reflex part means the question for the users or the student is that you have to write the difference between open system interconnection model and the transmission control protocol, that is TCP/IP model, in your notebook or journal. Thanks for watching this video. Thank you.